Lesson 824, this is an example for problem 890. So in problem 890, you're going to be looking at a few different types of graphs, and I just want to go over a few examples so you can understand some of the different situations you might be studying. All right, so if you look at the first graph here, I can see that my parabola opens up, and this is just a quick little sketch of a graph. And I can see that I have my x-intercepts. And so when I am building my equation from my graph, I need to know what my x-intercepts are. So I'm assuming that I'm I'm scaling by ones here. So my intercept right here would be at -1, 0. And then my intercept right here would be at 1, 0. So just like the last couple problems you did, you need to use those intercepts and work backwards to get the factor form. So this first factor would be x plus 1, because when you were to set that equal to 0 and solve for x, you would have got this -1. And then my next factor would be at x minus 1. Because if I were to take x minus 1 and set it equal to 0 and solve for x, I would get back to 1. Okay, so there is the area as a product. So you could go ahead and do a generic rectangle and get the area as a sum. All right, so we notice in that example, we have two different x-intercepts. In this next example, I'm noticing that my parabola only hits my x-axis one time. Okay, so I want to write down what the coordinate point is for that x-intercept, and it would be at -2, 0. Okay, but I'm noticing that it's a parabola. So I know that that makes it a quadratic equation because it's going to have an x squared term. So that tells me that one of my factors has to be x plus 2, because if I were to take x plus 2 and set it equal to 0 and solve for x, I would get this -2. But if that's my only root, then this must be a perfect square trinomial, and I must have two of those same factors. So I can write that like that, or I could rewrite it like this. And so that's my area as a product. If I went through and did my generic rectangle, I'd get my area as a sum. Okay, so when we are seeing a parabola that touches our x-axis once, that is just meaning that we have two copies of the same factor. So in this case, x plus 2 times x plus 2. Going down to this next example, I'm noticing something different here, and my parabola, instead of opening up like the last two examples, this one is opening down. So same thing as before, I'm going to take a look at these roots, and I'm going to write down what those are. So my this is at -3, 0, and my other one is at 1, 0. All right, and I want to do the same thing, work backwards. If I know that these are my x-intercepts, well, what would my factors have been? This first one would have been x plus 3. Because if I take x plus 3 and set it equal to 0 and solve for x, I'll get -3. Then this factor over here would have been x minus 1. Because if I take x minus 1 equal to 0 and solve for x, I will get x equal to 1. So there is the area as a product, but this opens upside down, this parabola does. So to show that it opens upside down, I have to put a minus out in front of my factors.